Hey guys, welcome back to my YouTube channel. In the last video, we got a look at the functional block diagram of our SOM board that we're going to be working on. Today, we're going to look at the datasheet of Allwinner H616 SOC. Okay, so let me find the datasheet of that SOC. I see it. Okay, I kept it inside this YouTube folder. So let me go ahead and double click on it. Okay. So here's my data sheet for Allwinner H616. So let's go ahead and double click on it. Okay, here it is. So this is the data sheet of our SOC, which is highlighted high picture quality 4K decoding SOC. Okay, let me scroll down. Okay. Okay, here is my CPU architecture, which is quad-core ARM Cortex-A53 processor. Believe it or not, the clock speed of this processor is 1.5 gigahertz. Down here we have GPU architecture, which supports OpenGL ES 1.0/2.0 and 3.2. Okay, and then we have memory subsystem. This SoC has on-chip boot ROM. It also supports booting from SD card or eMMC memory. In our system, SD card is intended to boot OS. Okay. Other than that, we have NAND flash, SPI node flash, SPI NAND flash, support secure boots and normal boots, support mandatory upgrade process through SMHC0 and USB, secure room support, load only certified firmware, secure from ensure that the secure boot is a trusted environment. Okay, this is the SDRAM interface. It supports these varieties of DDR memories like DDR4, DDR3, DDR3L, LPDDR3, LPDDR4 interfaces. Okay, in our system we're going to be using DDR3 memories, and it has the memory capacity up to 4 gigabytes. Okay, here is the system block diagram of the SoC. And then we have OTT box solutions of SoC H616. Alright, we have pin quantity. We have total 284 balls of our SoC, which comes in BZA, stands for ball grid array. Okay, here we have pin characteristics, I for input, O for out. These are terminologies which you are already aware of. Okay, and down here we have pin characteristics table. So this is the ball name, and on the right side we have in this column we have pin names like T21 is for address 0, U17 is for address 1. So these are the address bus for interfacing our DDR3 memory in our system. Okay, so this is important while creating our component library. Right, so go through it. And let me scroll down. So okay, this is important now, which is power and sequencing. Now, why is power and sequencing? Okay, to power up the processor and then the whole system in a correct way, the voltage regulators and other power on devices must provide the processor with a specific sequence of power and resets to ensure proper operation. Okay, so let me zoom it in. So this is the power and sequencing diagram, and based on that, we're going to be creating our power supply circuit of our SOM board. So notice that these voltage levels are not powered up at the same time. Alright. Okay. Now you can see here 1.8 volt and then 2.3 volt. These two voltage levels are powered up at the same time, and after some milliseconds, this many voltage levels, which are 1.1, 1.2, okay, 1.35 and then 1.5 volt, and then down here 0.9 volts are powered off. Okay, so this is important. Okay, it is left lane, and then This is pin mapping. Again, this is important while creating our component library. And most importantly, our package dimension. And based on that dimensional table, we have to create our own component library. The ball paths, as you can see, the fits between these two balls, which is being depicted with E is okay. Let me zoom it in. E 0.65 millimeter, which is pretty fine ball pitch. Okay, this is all about our SOC 8616. I mean the part of our SOM board. Go to the internet. It is readily available on the internet. You can download it. Okay. So now let us move over to our ultimate project. So, this is the pattern sequencing diagram which I created in my project. Okay, sorry, in our project, and it is simply copied from my data sheet. Okay, and then we have file tree. Okay, you notice this. This is my PMIC. Okay, power management IC, which is power externally with plus 5 volt DC. All right, it has three buck converter, DC-DC1, which is responsible for delivering 0.9 volt, and this is also 0.9 volt for BDD CPU, and then DC-DC3 for 1.5 volt for BDD DRM, and then LDO 1.8 volt for BCC 1.8 and DLDO BCC 3.3 volt. We can also create one sub, branch of this part 3. Okay, for my BTT regulator. So let me go ahead and create it right now. So okay, I can copy this, copy, and then paste. Alright, this is my BTT regulator for BTT ferrule termination register for DDR3 interface, and then also DDR3 VREF. I mean reference voltage. So I'm just gonna go ahead and copy and then paste because I'm a lazy guy. Also, I don't have much time to play around with that. Okay, yes. Hmm. Maybe I have to copy it manually. Alright, copy it. And then in order to power off, I'm using this external 5 volt DC input. Right. This is just too long. A little bit more. Okay, I make medium or is black. So in order to power it up, we need external 5 volt DC voltage. Okay, and we have one fin enable. Okay, in order to initiate its operations and whatever the operations it has to execute or it has to perform, like voltage conversion. So to do that, we have to input this 3.3 volt for enabling this. Sorry. Okay, I'm gonna copy it. This is 3.3 volt. medium. Alright, now we have to have 1.5 volt in order to create have a bit, I mean BTT termination resistor, which is 0.75 volt in our case. Okay, so I'm gonna take this. Alright, this will be my reference voltage for creating the exact BTT voltage. So I'm gonna create the output of this is going to be right, copy and paste is going to be how bit. Okay, BTT voltage, say BTT regulator, make it bigger a little bit and then make it black. Alright, this is my BTT. Alright, this is my power tree diagram, and based on this power tree diagram as well as power and sequencing diagram, we're going to be creating our power supply circuit of our system. Okay, just go ahead and save it. Okay, and in the next video I'm going to be talking about power supply circuit of our SOM boards. So